Okay. Hi, we're back with the Flappy Birds. We are almost ready to get the bird to jump here. Some of this you're going to have to figure out yourself for homework, but I'm just trying to show you what you can do with this. Um, and basically, we're working in Flappy Bird. This is our new class, which extends the character class. The character class is a very big, complicated class. It has a lot of stuff. It loads all the videos, right? All the images. Um, but it's great. So what we do is when you want a Flappy Bird, you call up the constructor for the old class, get that made, the parent class, get the pictures loaded, does all the work, does everything it does. But what we're finding is that if you make your variables private in the parent class, they're actually private to the children. So you still have to use these accessor and setter and getter methods. So we're going to do that. Okay, and what we found out was that instead of using myloc, set myloc, we wanted to do this, and we wanted to set the loc to be the yloc plus the dy is what we're trying to use here. But we have to use actually like this dot get my dy, which is like an accessor function that we wrote. Okay, and let me see. Oh, and I have to go like this. So what we're doing is we're saying like whereas in the past we had said like this dot basically in the move me what we did up here in the parent class, you can go like this and set yloc this way. What we have to do is we have to use like the setters and getters that belong to the class to do it. So then we have to do this same thing here too. Okay. So I'm going to use this and copy it. I'm going to paste it here and say get my xloc. And I'm going to paste it here and say get my yloc. Okay. And there it is. Okay. So what we did is we set a yloc, and what happens is when we say jump, okay, it's going to set the dy to 20. And then it's going to go like this. Okay, so let's give this a try. Okay, so here goes. Okay, ready, go, boom. Okay, it's sitting here, it's waiting for me to hit a key. Right now I have it set to any key too. We don't have to use the arrow keys, we don't have to use anything, but we can go, ready, go. There it goes, it's gone. Now how do you get it to stop? That's really the question. And right here, you will write some code to make the Flappy Bird go up and come back down in a realistic kind of way. Okay. Okay, so what would that entail? Basically, it entails you managing the speed variable. Okay, and what happens in a jumping situation? Let's take a look. Okay, so let's look at this for a second. This is a great video by a guy named Phil Vogel.
On Earth, we know that pretty much wherever they are, there's going to be gravity acting on them and pulling them down towards the center of the Earth. So we can go ahead and start this off by putting in a downward force here, representing gravity. This is just one thing. We know that since objects will attract each other through gravity and Earth is very large, it's going to have a decent tug on the person. We can also think about what else could be exerting forces on the person. So we'd look around in the diagram, think about what this means, and we can see that the person's standing on the ground. Because they are on the ground, it is very likely that the ground is exerting some kind of force on the person. In this case, it's supporting them, it's holding them up. And so we can think about this as there being an upward force from the ground. So we can draw that as our first picture of what's going on here. What that's a little bit more difficult, though, is thinking about the relative magnitudes of these forces. Is gravity going to be stronger? Is the force of the ground going to be stronger? And this is one of the limitations of starting with the individual part, because we don't necessarily know that. And in order to figure that out, we're going to have to go and look at the net force. As we've mentioned in class, net force is very closely tied to acceleration. So we start thinking about what the acceleration is going to be for the person in this situation.
Okay. I'm going to stop this. I'll put this video that you can look at, on Canvas. But basically what you're doing is this right here, when you set this is like the net force. And what happens is that basically 9.8 meters per second means that this will go down 9.8 meters per second, um, every second. It goes down by 9.8, right? So like after 1 second, let me go like this. Okay, so if we had 20, after 1 second, the velocity going upwards would be only 10.2, okay? And after another second, the velocity would be only 0.4. And then after another so this is like almost like the top of the jump, right? And then after another second, if you subtract 9.8, it's going the other way now. So it'll start going down, right? Okay? So that's sort of like the the thing. Like let's do this in pixel like land too. So we start out with 20, okay? Or actually start out with negative 20. What's going to go on here? Sorry, let me just let's go to like negative like 20. I don't know if I can do. Oh, sorry, I got to do this. Negative 20. There you go. Thank you. And then what happens is after 1 second, it's going to be 9.8, right? Okay. So what happens too is that we're doing, like right now we're running this at 50, like we're running this in 50, like the second is like this divided by 1,000. We're running this in 50 milliseconds. So this is, whoopsie. We're running this 50 divided by 1,000 is this. Okay, so we're running it in like 0.05 second, increments, right? So if it's 9.8 meters per 1 second, right, it's going to be 9.8 times 0.05. That's how much the change is per tick, okay? So what's going to happen here, and we'll try to do this, right, is we're going to try to subtract, and what's going to happen is that every tick, it's basically going to change this right here. See this, like get my dy, right? And we're going to have to actually reset the dy. We're going to kind of like keep changing the dy down here until it becomes 0, right? Or until the so you're gonna basically work and like move them. Okay, so the procedure is like step 1, move, which we're doing up here. This is the move, right? Adjust the dy for the next move. Okay, that's really like step 2. Okay, and I'm going to leave this to you to kind of figure out how to do this. And then what you're going to do too is there's sort of a proviso, provided 1, if the speed becomes 0, then stop it. Like don't let the speed, like don't let them go like back up again, or don't let them get too negative, right? Let's see, or actually it's sort of like this, provided like if the Flappy bird reaches the ground again, then stop him. Or her. Okay, so that's basically what's going on. I think that will actually cover it. Okay, and we don't really care. And then to do that, then you just stop them. Stop them means, let's do this. Stopping the Flappy Bird means setting the dy to 0. Okay. So I'm going to let you guys try to figure out if you can do this. That's really the challenge here, okay? If I can get mine working, I will show you it, but I won't, like, you guys can kind of figure out the programming. Basically, once you get this running, to here, and maybe that won't happen either. But give it a good try. Okay, you get points for trying always. Then you want to go for this extra part. I want to see if you can figure this out. Okay. All right. Thanks. What I'm looking for. Okay. Oh, I gotta give it to here. There you go. So you want a Flappy Bird that flaps, right? That's what we're looking for. Flap, 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 flap. And we can work on this, but that's the idea. And then when it comes down, it'll like show up there. See, that's good. That's what we're looking for. See how it kind of comes back. I didn't make it bounce. You could kind of make it bounce on the ground, but it goes away. But it'll come back. There you go. Flappy. Yes. Okay. So see if you can figure this out. I'm doing this on the press bar, space bar. Works on any key though. See right now. You can have it work on special keys, but we don't really care. We just want it to work like this. Okay. All right. So that's what we're trying.